In this video, we're going to continue with the AC method, but the value of A isn't going to be a 1. I'll run through this first one to show you that the procedure you've been working on fits with what we do now really well. First, I need to find the product AC, and in this case, since A is 8 and C is 3, A times C will give us 24. As before, the value of B will be 10. Next, I need to find all factor pairs of 24, and again I work off the prime factored form, so here they are. It's 1 times 24, 2 times 12, 3 times 8, 4 times 6, there's no factor of 5, and then I get to 6 times 4, so I'm starting over again, so I can stop. Now I look through these pairs trying to find one which might add up to 10. Notice again that there are 2 that might work. 2 and 12 would add up to 10 if the 2 was negative, and 4 and 6 would add up to 10 if they were both positive. To decide which is the right one, I'll start with my first choice. If the 2 was negative and the 12 was positive, it's true that that would add to 10, but it would multiply to negative 24. I need a positive 24. On the other hand, the 4 and the 6 add up to positive 10, but most importantly, they also multiply to a positive 24, which is what I need. So the right pair is 4 and 6. Now I return to my trinomial and rewrite it as 8a squared plus 4a plus 6a plus 3. And again, the coefficients for my first degree terms come from my factor pair. This is my 4a and this is my 6a. Now I factor by grouping, and then I multiply to see if I get my original trinomial back. This will give me 8a squared. This will give me 6a plus 4a, which is 10a, and this will give me 3. Here's one for you to try. In this problem, A times C will give us 10, and B will be negative 7. There's only a couple of factor pairs for 10, 1 and 10 and 2 and 5. The only one that might add to negative 7 is the 2 and the 5, but only if they're both negative. Before I move on, though, I'm going to check to make sure both criteria are met. Negative 2 times negative 5 will give us positive 10. Negative 2 plus negative 5 will give us negative 7. So I've found my pair. I return to my original trinomial. I'll have 10z squared minus 2z minus 5z plus 1. And again, my coefficients negative 2 and negative 5 come right out of my factor pair. Now I factor by grouping, and I check to see that I get my original trinomial back. This is 10z squared minus 5 minus 2z will be negative 7z plus 1. Try this one. Here my value of AC will be 2 times 35, and I usually don't find that product, even though I know it's 70. Instead, I'll just write 2 times 35 in the form of 5 and 7. Then I can easily get my factor pairs. That is, it's 1 times 70, 2 times 35. There's no factor of 3, no factor of 4. 5 times 14, no factor of 6, and 7 times 10. I'm now looking for a pair that might add to a negative 19, and here it is, as long as they're both negative. I then check just to make sure that both criteria have been met. Negative 5 and negative 14 will give me a positive 70. Negative 5 plus negative 14 will give me a negative 19. I'll rewrite my trinomial as 2x squared minus 5x minus 14x plus 35. And then I'll factor by grouping. You should always multiply to check. 2x squared, negative 14, negative 5 will give me negative 19. And then when I multiply my constants, I'll get plus 35. Here's one that's a little unusual. See if you can figure it out. We're starting with a binomial, but we could make it a trinomial if we thought of our first degree term as 0 times h. Our value of AC then would be a negative 36, and our value of B would be 0. Using my prime factorization, I find my factor pairs. The pair that could add up to 0 would be 6 times 6, but only if one of them was negative. Negative 6 times 6 does give me negative 36. Negative 6 plus 6 does give me 0. So I can return to my original trinomial and write it as 9h squared minus 6h plus 6h minus 4. And then I would factor by grouping. When I distribute, I'll get 9h squared, and then I'll pick up opposites. That is, I'll get 6h, but I'll then lose 6h. And finally, I'll get negative 4. Try this one. First, I'd write in standard form. AC would be 42, and B would be 43. Using my prime factored form, I'd generate my pairs, and find my pair is 1 times 42. The product is positive 42, the sum is positive 43, so I return to my trinomial and write 7y squared plus y plus 42y plus 6. Last, I factor by grouping. Make sure you multiply to check your work. And here's our last one. First, I have to find the product of 18 times negative 4, and that's negative 72. My value for B is negative 21. Of course, I don't work with the negative 72. I work with 18 and 4. That is 9 and 2 and 2 and 2. I then use my prime factored form to generate my factor pairs, and I look for one that can give me a negative 21. So again, I'll use this pair, but I'll have the 3b positive and the 24b negative. If I multiply them, I do get a negative 72, and if I add them, I get a negative 21. So my trinomial will be written as a 4-term polynomial in the form 18z squared plus 3z minus 24z minus 4. And then I'll finish by factoring by grouping. Well, that concludes this video where we've practiced the AC method.